Okay, sorry. Okay, so we're going through examples of acids and bases according to Arrhenius and Lowry Bronsted. We have phosphoric acid reacting with water. In that reaction, phosphoric acid donates a proton to the water where it forms a dative covalent bond to make oxonium ions in the solution. Right, so phosphoric acid is an Arrhenius acid because it increases the concentration of the oxonium ions in the water. Earlier this week I showed you that water naturally ionizes to form H3O plus and OH negative ions. Okay? Phosphoric acid is a Lowry Bronsted acid because it gives a proton. Water is a Lowry Bronsted base because it accepts a proton. Okay.
Ma'am?
Yes.
Can I ask, in the terms of like if it were to be a question in the paper, would we have to first balance the equation and then answer it based on this, or would you give us already in advance?
You can answer these questions without balancing the reaction equations. Okay. This thing, the H2PO4 negative, has two more protons to give. So I'm going to write it. If it's in the presence of water, the chance is that it will give another proton to the water. If it gives another proton to the water, it is a Lowry Bronsted acid. In the process of giving another proton to the water, it forms HPO4 2 negative and H3O plus. So once again, it increases the concentration of the oxonium ion, and therefore it's an Arrhenius acid. So this is an Arrhenius acid as well as a Lowry Bronsted acid. And the water is a Lowry Bronsted base. Yes.
There be one way it's like Arrhenius spotlights and not Lowry Bronsted.
Yes, there are Lowry Bronsted you can apply everywhere. It's the more modern definition of acid or base. Arrhenius you can only apply when oxonium or hydroxide forms.
And why is it HPO4 2 negative and not H2PO?
Well, the H2PO4 negative has donated another proton.
So Lowry will just tell you if it's an acid base.
Yes.
Ma'am?
By accepting or donating a hydrogen ion called a proton.
Oh, it has to be hydrogen.
It has to be hydrogen because it's a proton donor or a proton acceptor.
So, ma'am, what is that?
What is what?
What is the...
This is the dihydrogen phosphate or the hydrogen phosphate negative ion. This is the monohydrogen phosphate ion.
Ma'am?
No, because it doesn't increase the concentration of the hydroxide. Not in this example. It's possible, but not in this example. I'll do another example.
Ma'am, can you also do an example where we won't have Arrhenius like an OH or H3?
I'm getting there. Sorry. This thing called monohydrogen phosphate ion, that thing, PO4, 2 negative, can donate another hydrogen to form the phosphate ion. And increasing the concentration of H3O plus. Something like that is called a polyprotic acid. So the H3PO4 is a polyprotic acid. It means it can donate more than one proton. It's got 3 protons to donate. So to be very specific, it's a triprotic acid. Sulfuric acid is a diprotic acid. Hydrochloric acid is a monoprotic acid. It's got one H. Nitric acid is monoprotic.
And these are the chlorine.
Ethanoic acid is monoprotic. Oxalic acid is diprotic. Who's mamming?
How do you know that sulfuric acid is
That's too much.
What is its formula? So it's got 2 protons to give.
Two hydrogen protons.
2 protons to give.
So, ma'am, one that had 4 would be
Tetraprotic.
tetra.
Yes. But I don't know about one with 4. At school level you won't go 4. You get mono, di and tri.
Ma'am, you have to know those names, like try. Ma'am, it's going to be indicated by the 3.
Tri means 3
Ma'am, I understand.
hydrogens. H3PO4.
Is it only with hydrogens or everything?
Hydrogens. When ammonia is mixed with water, we did do this one last week, earlier this week. When ammonia is mixed with water, the nitrogen tends to draw the bonded hydrogen in the water towards it. So the proton will go from the water to the ammonia. It's magic of creation. There is no why. It's because the bond between the hydrogen and the oxygen is no, I don't know why. It's I can't say it's weaker.
So in the test, are you going to give us the
Bond
reactants
in.
and the products?
The what?
Are you going to give us the reactants and the products? Or are you just going to give us that and say, first make the products and then
Just
bind?
mind that pen close to Kramer's eye, please. You should know the common ones. So here, the nitrogen will take the proton from the water, and it will make NH4 plus and OH negative. So this is, according to Arrhenius, this is an Arrhenius base.
And H2O is in the Arrhenius acid.
No, H2O is nothing in terms of Arrhenius.
What do you
Arrhenius base, because it increases the concentration of the hydroxide in the water.
So the water is made up of lots of oxonium
Oxonium and hydronium, yes, and hydroxide ions, yes. Well, a very small percentage,
So, and
but they're
all it's
there.
doing is increasing it so that it becomes.
Yes. The ammonia increases the concentration of the hydroxide ions in the water.
Oh yes.
I'd like to finish my explanation and then answer your question. Okay? This is also a Lowry-Bronsted base because it is a proton acceptor. The water in this case is a Lowry-Bronsted acid. It is nothing in terms of Arrhenius. Arrhenius does not define the water as an acid because the water is not forming the oxonium ions. Okay, Tina. You had a question just now.
I was gonna ask. I was gonna ask, ma'am, how come the NH3 is Arrhenius base, but not the water? But the water is the one that's given away. I mean, well, the water is the one that's given away. So isn't that given away? Yes,
Giving away means Lowry-Bronsted.
Yes, ma'am, I understand that, but like, I mean, like, you see, since the water is the one that's giving away the hydrogen in order to make it a hydroxide, wouldn't that then mean that it's the Arrhenius base?
No, read the simple English words defining Arrhenius base. No, read. You wrote it down or it was written down. Read the simple words that defines an Arrhenius base. Please.
An acid is a compound that increases the concentration. Base. A base is a compound that increases the concentration of hydroxide ions.
That's it. That's an Arrhenius base. Which chemical here increases the concentration of the hydroxide ions? It's the ammonia because it is taking the hydrogen from the water. Okay? If you mix something else, it won't happen with the water.
Is it only with ammonia?
No, it is not only with ammonia.
In the test, there's not going to be like an arrow that's going to like show us that.
Don't
No, I'm not
stress,
asking,
it's
I'm
not asking
saying.
silly questions.
I'm not asking. Ma'am, I'm not asking. I'm saying, since in the test there's not going to be an arrow that indicates that the hydrogen is moving to ammonia, then like.
Learn.
Learn.
H. Next one. Sorry. Excuse me. HCl and H2O. We have H3O plus and Cl negative. I wanted to write these two equations on the same screen so that I can go for the next definition that you need to know. This is a Lowry-Bronsted base. Okay? There the water is an acid. Here the water is a base. Chemicals that could either act as an acid or a base, depending on what you mix it with, is called, yes, water, H2O, is an ampholite. Some books says amphoteric, ampholytic. So ampholite, amphoteric, ampholytic, all the same thing. It means that substance can act as an acid or a base depending on the reaction it is part of. Acid. What is the acid here? What?
The
Is it the HCl or is it the H2O?
it's the HCl.
It's the HCl. This thing is the Arrhenius acid because when it reacts with the water, it increases the concentration of the oxonium. The water by itself can't increase the concentration of the oxonium. Okay. Is a very strong acid. So it means that sulfuric acid will react with water and it will form a high concentration of oxonium ions.
I'm trying to switch my
Is this the one where you shouldn't add water?
Yes.
Okay. Ow.
Now, the new thing that I'm going to show you is that this reaction is reversible.
How?
So they can
It can go back, you can remove the water, and then H2SO4 will be present again. So it is a reversible reaction.
Can we do that?
I'm going to do that.
Stop it.
HSO4 negative, the hydrogen sulfate ion will form, and H3O plus. Now I want to concentrate on Lowry-Bronsted definitions, because I have introduced the fact that a reaction like this is a reversible reaction. And I deliberately made the arrow that points back shorter, because this is a strong, no, it's a strong acid. It won't reverse easily.
So it's not enough. It doesn't happen enough.
So does it?
No, it happens all the time, but not the percentage of it that happens is less.
Yeah, that's what I mean.
So when you reverse it, is it as strong or is it a bit weaker?
I'm going to talk to you about that now. This is a strong Lowry-Bronsted acid. This acid is literally married to that thing that is a Lowry-Bronsted base.
Yes. I'm going to put LB.
Yes. LBB. Lowry-Bronsted base. LBB. LBA. Not in a script, but you can in your study notes. Yes. Okay. This will be a weak Lowry-Bronsted base.
WL.
Okay. This is a Lowry-Bronsted base.
We love clean Brexit. WL.
And that thing that is married to this base is a Lowry-Bronsted acid.
This is insane.
I was asking if the one that side, the HSO4, yeah, isn't it actually an acid?
We're getting there.
It's
You're very clever. We're getting there. Just give me a chance to explain what I'm explaining now. Okay. Because the H2SO4 and the HSO4 negative is literally married, it's called a conjugate acid base pair.
Ma'am, what is the definition of conjugate?
It is the base formed from an acid.
The base formed from an acid.
And conjugate, if you look it up in the dictionary, will mean married.
Oh!
H2O and H3O plus is another conjugate acid base pair.
So, ma'am, even if it's a base first, it's always acid base.
Yeah, A for B. A before B.
What? Oh.
If I say base formed from acid, I have to say the base. You have to say the base.
That's right.
The.
Oh, the reverse reaction.
Also, ma'am,
Phosphoric acid, let me finish. Phosphoric acid is the acid in the forward reaction. It makes the hydrogen phosphate ion, H2PO4 negative. So this is in the reverse reaction, this is the base. Okay? The water is the proton acceptor, so it is the base in the forward reaction. Going that way, it makes the conjugate acid. So this is another conjugate acid-base pair. In the reverse reaction, that H3PO4 will be the acid. In the reverse reaction, the H2PO4 negative will be the base. But it is formed from this acid. That base, this is the base, that is the conjugate acid. So conjugate acid-base pairs.
So, ma'am, what I'm picking up is you mustn't think of the compounds as acids or bases, but you must look at them from the reaction as to what they are.
Yes. So in this second step, where the second proton is given to the hydrogen, the H2PO4 negative is the acid. In the forward reaction, it makes the HPO42 negative. So this is the conjugate base. This is the base. In the forward reaction, it makes H3O plus. So this is the conjugate acid. In the reverse reaction. Sorry, Lucidi, Tina.
I wanted to ask, is this only in reverse reactions?
Yes, conjugate acid-base pairs are present in reversible reactions.
Okay.
So now it's also the acid-base to conjugate, what
Yeah.
the conjugate to acid.
Yes. So together they called a conjugate acid-base pair. This is, in this reaction forward, an acid. That is the base, according to Lowry Bronsted. This is in the reverse reaction. It is the base. So this is the conjugate base that is formed from this acid, and this is the conjugate acid. Okay. So compounds that can, depending on how you look at the reaction, can be a base or an acid. Those are Ampholytes. Those are ampholytes. If they are married, they're in the same reaction. They are conjugate acid-base pairs.
Wait, what's an ampholyte?
And
It's something that can both be an acid and a base.
here we have another compound. There it's a base in the reverse reaction. Here in the forward reaction it is an acid. So those two are conjugate.
Ampholytes.
Sorry man. Ampholytes.
Conjugate ampholytes. Conjugate
They are ampholytes.
ampholytic conjugates.
So water is an ampholyte, and any ion formed from any polyprotic acid can have ampholytes.
Polyprotic.
Yes.
Can you please explain polyprotic one more time?
No, man.
Sulfuric acid is polyprotic. Because here it gives one proton to make HSO4 negative, and that HSO4 negative can react further with H2O to make H3O plus and SO4 2 negative.
Isn't that
So the sulfate, the sulfuric acid, has two protons to give. So it is actually polyprotic, diprotic, because it can give two protons.
so
This is now
polyprotic is just like
can give more than one proton.
Ma'am? So if we were looking at that side of the reaction, but the top, would then the H in mono? That side, ma'am.
This one,
Yes.
but this one doesn't exist by itself alone. HCl is monoprotic. HNO3 is monoprotic because it can only give one proton. Ethanoic acid is monoprotic.
also that
Carbonic acid is polyprotic. No, please, wait.
when you say it doesn't exist, you mean like as a substance?
It doesn't exist as a substance by itself.
Oh,
It will be connected to something. Okay. I couldn't finish this now.